In this next module, we're going to begin talking about the ACI fabric or physical layer policies. So to begin with, we'll talk about the initial configuration, some out-of-band management configuration, really how to accomplish this. We've talked about it from a theoretical standpoint already. How to configure network time protocol. Might seem trivial, but it's very crucial to the ACI fabric. And then we'll talk about access policies. Things like external facing interface configuration, switch configuration. We'll move on to ACI domains and pools. And then we'll talk about the attachable entity profile, a little bit about VPC configuration, and actually we'll probably save troubleshooting for another complete module all of its own. So to begin with, let's take a look at the initial configuration overview. And one of the things we would just kind of like to do at the outset is kind of map the traditional 7-layer OSI model for network engineers to the ACI logical model. So some of these things, some of these terminology we've already introduced, and we'll be unpacking them in a lot more detail in this particular, actually in this and the next module. But on the left, you can see that we have our 7-layer OSI model, application, presentation, session, and transport, as well as network, data link, and physical layer. So our physical layer maps in our ACI to our physical switches, but from a logical standpoint, it maps to things such as our access policies, our AEP or attachable entity profile, and then domains such as either physical domain or virtual machine manager. And again, we're going to explain what all of these are in this particular module. At layer 2, the data link layer, we have the concept of a VXLAN bridge domain. This would have traditionally been a VLAN. We also have policy groups, things such as either VPC or traditional port channel or interface policy groups, along with their encapsulation, whether it's VLAN, VXLAN, or NVGRE that's coming in from the southbound ports into our leaf switch. At the network layer, we have the bridge domain, but specifically the subnet or SVI. We also have the layer 3 private network or VRF. And then at the really application, presentation, session, and transport, so layers 4 through 7, we have our contracts, graphs, application network profiles, and endpoint groups. And we're going to discuss these in the next module. So some of the initial configuration steps that we need to do are to be on the Fabric tab. And we can really break down some of the specifics into two major roles. So if we had multiple different administrators administrating the ACI fabric, the infrastructure admin would be responsible for the Fabric tab, and they would do things like fabric discovery, out-of-band management setup, configure NTP, configure the access policies for interfaces or ports, tie those to switches, create VLAN pools, create physical or virtual machine domains, configure the AEP, and then they would probably create the tenant and the tenant admin roles or role-based access control RBAC. Then we would move on to the tenant, and the tenant admin would be responsible for doing things like creating the VRFs, the VXLAN bridge domains, associating EPGs with either physical or virtual machine domains, and then associating the EPGs to bridge domains and to private networks or VRFs. So really all of this would be or will be covered in the next module. So let's talk about out-of-band configuration for management. So we've already talked a little bit about this in one of the previous modules, but we're just going to briefly review it. We've seen the picture of the C220 server, which is the APIC controller, where the leafs, or where the APIC plugs into the leafs, where we have a dedicated SIMC or shared SIMC along with out-of-band APIC management. But here is where our APIC out-of-band management interfaces are. And we start by configuring that. If you recall, in the very first wizard, when you bring up an APIC for the very first time, and before you go through Fabric Discovery, if we were on the APIC, we would see, especially if we did a, let's say, an ifconfig, or the newer command IP address show dev for the device, and the name of the device is OOB MGMT, so out-of-band management. On leaf switches and spine switches, really all of our nodes, we do have a dedicated 1 gig out-of-band management port, as well as a console, but this has to be configured separately. So one of the things we talked about was how the wizard will automatically, and really we kind of forced to, create the out-of-band management for the APIC. But in terms of configuring the out-of-band management for the switches, this is where we need to move on to the next screen and do this either through the web user interface or through the RESTful API. So this is actually something that's done on the Tenants tab, and most specifically on one of the 3 built-in tenants. So there are 3 built-in tenants that cannot be deleted. Those are MGMT for management, and this is for user management. The APIC automatically manages the fabric through the infra tenant or infrastructure tenant. And we already talked about it has a dedicated VLAN that we recommended you change from 4093 to 3967, and it has a dedicated VRF. We typically colloquially refer to it as the infra VRF or infrastructure VRF, but technically it's labeled overlay-1 in the fabric, in the leaf and spine switches. So from the navigation pane for tenant management, we go down to node management addresses, and we can either create node or static node management. So we could give it a range, and we can tick the box if we only want to configure out-of-band addresses, or we also have the ability to configure in-band management addresses. Now this is a very important decision that you need to make, because you don't just want to do this lightly. So I would not just want to tick the box for out-of-band and in-band management, because as soon as I do this and I configure in-band, it will be preferred over out-of-band. And by default, the fabric won't really respond to the out-of-band because it's focusing on the in-band management. Okay? So the only time it would fail over to the out-of-band is if there were actually a link failure. Okay? Not just the unreachable. So you do have to know that you want to configure in-band management as well. So these are, this is the ability to configure the ACI fabric, leaf, spine, and even APIC from a device that's attached in band to the fabric. So in other words, from a device that's attached directly to a leaf switch. Could be a VM, could be a, which would be indirectly attached. Really is attached to some VTEP, whether it's a leaf switch or possibly even a software switch like the AVS, Application Virtual Switch, that we'll talk a lot more about later. Now, when we configure, let's say, our out-of-band management addresses, we need to specify a node range. So here we might have 10 leaf switches, or really even could be our spines as well. And we're simply allowing a starting address and a mask. And of course, we can always do / notation. It will automatically fill in the mask field, as well as the out-of-band gateway. So it'll start at 101 and go up from there, automatically increment to 110. If you like, you can also be specific and say node range from 101 to 101, and then just give it the IP address for node 101. And then you can create another static node management address for 102 to 102. So the starting and ending node range would be the same, and your starting IP address would be the IP that that node gets. So to verify this, we would simply look at our static management node addresses, and we can see, in this case, we have both out-of-band and in-band. So every node has 2 IP addresses, and to gateways. So now let's talk about NTP, or Network Time Protocol. So first of all, NTP is critical to the system. There's a lot of things such as atomic counters, some of the advanced dynamic load balancing and flow prioritization that we can do that essentially do not work unless we have at a minimum NTP configured, preferably PTP, Precision Time Protocol, but NTP is enough. So we do have to have that configured in order to allow our fabric dynamic load balancing, flow prioritization, or atomic counters to function. So there's two different policy types under the Fabric tab. We see fabric policies here, and then we see access policies. And then we also see inventory to more or less view things. A couple changes we can make there. But most everything's broken down into fabric policies and access policies. Fabric are interfaces that connect leaf and spine switches together. Those are the fabric themselves. Access policies are external facing interfaces. So basically the leaf switches only, and the southbound interfaces to servers, to routers, to other switches, things like that. So some examples of things that we configure under fabric policies are things like NTP, IS to IS for the layer 3 routing, BGP, which we'll talk about, is used specifically MPBGP, but not EVPN, at least not today, is used to allow connectivity and routes to be learned in one interface or in one leaf and redistributed to the same VRF on other interfaces. And then things like DNS. So to configure NTP, and we already mentioned it's critical to fabric operations, you first want to start by setting the date and time in the SIMC BIOS by pressing F2 when you first boot. Once you do this, then we can move on to the actual APIC once we've fully powered up, jumped into the web UI, and we can create a date and time policy. So we'll create an identity and then specify the NTP servers that are to be used in the policy, set the date and time format, configure the fabric pod policy to use your date and time policy. So we'll create a pod policy and then assign the new policy group as the default fabric policy group. So again, this is under fabric policies, and then here we see on the left navigation pane pod policies, and then policies, and we can see the kind of hierarchy up here, and then date and time. We'll right click and create date and time policy. The administrative state will be enabled. We'll give it a name. We can use authentication if we prefer. And then once we press next, we'll be on the NTP server and we'll create the providers, whether a particular provider is preferred or not. It's a good idea to always have one that's preferred. And then which management endpoint group should this go out of? Is the NTP server going to be learned through the out-of-band management, or is it actually learned in-band? So maybe the router or switch or device that we have providing NTP is directly connected to a leaf rather than to one of the management, and actually every leaf and spine switch would need the management 0 or MGMT 0/0 interface, that 1 gig separate interface, to be connected to an out-of-band routable network. And then from there, we'll go to the date time format, choose whether we want local time zone or UTC, and whether the offset is enabled, and then what is our time zone. From there, we created the policy and set the date time group preference. Now we need to create what's called a pod policy group, give it a name, choose the date time policy that we just set, and then finally, under the default, we have to assign the fabric policy group. Now this may seem like a little bit much work. Possibly may even seem a little excessive. Why do we have to do 3 separate areas? Well, first of all, if you've ever worked with Cisco Unified Communications, someone pointed this out to me the other day, I hadn't even thought of it, but you are pretty familiar with the kind of 3-layer device pool, and then groups. So really, kind of like actually, let's say a list, a group, and then the specific device or something like that. In ACI, we have very much the same three-tier construct for a lot of our different entities within ACI. So we almost always have a policy or multiple policies. Those get grouped together into policy groups. So first of all, the policy defines what it is we want to do. And because we might have multiple policies, we group the policies that we want into a policy group, and we might have different policies for different leaf switches or something. Maybe one's in one data center in one state or country or one time zone, and another is in another data center. So we might want to have different local time zones, something like that. So we could have two different policy groups, each containing policies that would essentially say the same thing and overlap each other if they were in the same policy group. And then, so policies get created, they go into policy groups, and then we have profiles. Now, in the case of the actual fabric itself, a lot of times we don't have a folder for profiles because we can't create multiple profiles like we can on things that we're going to look at next, like access policies, like interfaces and switches and things like that, where we might have multiple different ones. But in something that's fabric-wide, like an entire ACI pod, which is in one fabric, okay, then instead of having a folder called profiles, we simply have the default. And you're going to see this a lot more under fabric policies. So then we take on that default and we place the fabric policy group that we just created, and that is what provisions all of our leaf and spine switches as well as our APICs to use and sync up to NTP. So next, let's take a look at access policies. So again, the two types of policies, the access policies under Fabric Access Policy is where we're going to configure our external interfaces. So the infrastructure admin is going to categorize servers based on their requirements, okay? And really not just servers, but really anything that we're connecting to. Could be routers, could be physical switches, anything that we're physically plugging into our leaf southbound facing ports. So we're going to prepare the configuration templates for servers, for instance, active standby teaming or traditional port channels on a single switch, or even virtual port channels distributed across two VPC peer switches. And then we're going to group those templates or policies together into policy groups. So some of the external facing interface configuration steps that the infrastructure admin would perform would be, from a physical standpoint, configuring interface policies, things such as link speed, duplex, CDP enable or disable, LLDP enable or disable, LACP, even things like spanning tree, BPDU guards, spanning tree, BPDU filter. There's a number of things in here that we can configure. The next would be to group various policies together into policy groups. Then we create interface profiles. So the interface profile is basically what associates our physical interfaces. And then we tie those to our interface policy profile, or sorry, to our switch policy profile. And the switch policy profile is what links our interfaces to our switches. Now, all of this seems very complex. I'm going to be upfront and honest right now. I've got a couple of diagrams that are going to illustrate everything. Do keep in mind this is a logical, abstracted model. If you've worked with Cisco UCS, this shouldn't seem too abstract, right? We used to create in Cisco, well, we still do, in Cisco UCS Manager, we create things like initial or updating VNIC templates and VHBA templates. Those get included or associated to or used and consumed by server profiles, or really service profiles. And probably they get actually created into or associated into service profile templates. And then from there, we create instances or spawn or instantiate service profiles from our service profile templates. If you haven't worked with UCS Manager, you don't have to remember all of that. It's not pertinent for this particular ACI, but if you've worked with it before, it will help to remember back to when you first had not seen UCS Manager and all of a sudden you were introduced to all this abstraction, and you might have even asked yourself, this is too complex, why are we doing this? What's the point? And then the more you used it, you realized, wow, this is actually really powerful and it gives me incredible granularity. The same is true in ACI. And one of the things I'm going to say about this particular subsection of access policies is that the more you configure, really the more you plan and physically provision and attach things of like nature into the same switches for all of your leaf switches, the easier your life will become in terms of configuration. So for instance, maybe I have 4 tenants or 4 business units or something like that that I want distributed amongst my 20 leafs. Okay? I'm going to configure the same ports for each tenant. That might be one example. Another example might be, let's say I just have a single tenant or a single business unit or a single company. Maybe I even have multiple. Maybe it doesn't matter. But instead I want to group things together by type of device. So if I'm ever going to attach routers, they're probably going to be to a couple leaf switches that we'll designate as border leafs, although we don't have to do any special configuration for that. If I have any switches, maybe the same thing. If I have any physical or bare metal machines, I'm going to attach those always to ports, maybe 20 through 32. Actually, you know what? Let's say we have 48 ports. Let's say I'm going to attach those from 38 to 48. The last 10 ports will be used for bare metal on any leaf switch. And then the rest of my ports, so what did I say? 38 through 48. So 1 through 38, or really 1 through 37, will always be used for virtual machine hypervisors. Okay? This is going to make your configuration very simple, and you're actually going to see an example of this as we go on. So going back to the slides, we then have our logical model where we configure our VLAN pools, our domain, and our AEP. And I'm going to unpack and explain what all of these are in a lot more detail. So let's talk about the external facing interface configuration. And before we move on, let me introduce the Fabric Access Policies logical model. So this was a drawing that one of the TMEs, Carly Stoughton, did, and it's actually there's a great free book on ACI called ACI Operations. I'll provide a link for it in the class notes, and I'll show you on Cisco where you can find it, but it's out on not only GitHub, but it's also out on Cisco's site under their documentation, and it's a great PDF book that was collaborated by a number of people and actually written in a week. But this drawing is, I believe, on page 86 of that book, if I recall correctly. And this is, it's slightly, this was her original drawing, so it's slightly modified now. But at any rate, this kind of lays out the Fabric tab, and then what we're going to talk about in the next module, which is the Tenant tab. And the reason it's even slightly pictured here is we have this notion of an endpoint group, or EPG, and the EPG is what defines the who. So who is attaching to our fabric? This is how we classify who is being attached. The domain, which we see just to the right, that's associated to the EPG, this is how we learn or how we find out about classification of who is attaching to the fabric. So the domain contains a pool. Could be a VLAN pool, could be a VXLAN pool. So we need to know who is attaching, and we learn that by how, being the VLAN pool, are we learning how based on a VLAN, and if so, what is the VLAN ID? Is it a VXLAN? If so, what's the VXLAN VNI? So this is the domain setting. And the domain could be a virtual machine manager, VMM domain, could be a physical domain, meaning we have a bare metal machine attached. Could be an external layer 2 bridged switch or an external layer 3 routed. So those are our 4 different types of domains, and we'll unpack those more as we go along as well. Those link together with this, what I call software glue. Okay? There's really no physical component for this, or even necessarily logical, tangible component like a VLAN. But the AEP, or Attachable Entity Profile, is how the domain gets associated over to our interfaces and to our switches. So the AEP is where we find out who is attaching to our network and how, which is the VLAN pool. We'll talk more about the other stuff a little bit later in the next module. Okay, so again, the AEP denotes where we're attaching, which means a particular interface, which is linked to a particular switch. Now, when we get over to the interface profile and the switch profile, we note that an interface profile contains something called an interface selector. So an interface profile might have multiple interface selectors or basically multiple ports defined. And the reason we might have multiple ports on an interface profile is so that we could tie the same policy group of policies. So the policy group contains the policies, and the policies are, of course, what is the link speed? Is it 1 gig, 10 gig? Is it even 40 gig, or is it even 100 meg? Is CDP enabled or disabled? Is LLDP enabled or disabled? Is spanning tree protocol, actually, I'll just say this now, spanning tree protocol does not run anywhere inside the ACI fabric at all. We have a couple of nerd knobs we can tune for that. We'll talk a lot more about, but one of them is spanning tree BPDU guard, right? If we sense a spanning tree BPDU, we'll go into error disable. Another is spanning tree BPDU filter, simply drop and then allow that BPDU to transit. And we do allow BPDUs from spanning tree to transit the fabric, and there are some constraints, and we'll talk about those. But we do allow those to transit. So is LACP configured? And there are a few other policies that we'll talk about as we get into more into the specifics and also into the demonstration. But we group those policies that we've created into a policy group. So I might turn on link speed 100, CDP enabled, and LACP disabled. And I might name those policies and group those together into one policy group. Then I might have a different policy group that contains 3 new policies, being link speed 10 gig, maybe actually, let's say auto negotiation, CDP disabled, and LLDP enabled. So that would be another policy group. And when I create the policy group, I do have to state whether it's a access, a port channel policy group, or a virtual port channel, VPC policy group. And we'll talk more about that. So then the interface selector gets tied to the policy group, and then we tie the interface profile or selector over to the switch profile. Normally, we don't have to do anything with switch profile policy groups and policies, because about the only policy group is, for instance, multiple spanning tree regions. And that, again, we don't speak spanning tree outside of the fabric, but we do have the ability to define regions, so we can define where spanning tree BPDU are allowed to flood, and then also how topology change notifications, spanning tree TCNs, affect which endpoint groups and flush particular CAM tables. Okay, so normally we're not messing around with switch policies and policy groups too much. So at least a little bit less work for you to do. Okay, we'll be taking a lot more about look at this as we get into each subsection.